Okay, question 6. Which of these is a vector quantity? So it's one that needs a direction along with a magnitude. So that has to be A. The next one, tricky question this, loads of students got this wrong. So it tells us that the pivot is here, and it says the rod hangs by a string, and that makes the pivot there. And it says calculate the moment. Well, we can see that this is a meter rule, so these must be in centimeters. And it wants the moment is in Newton meters. The other thing that makes it tricky is you can't be lazy and just pick the 10. We need the perpendicular distance from the pivot. So we can see it's going from 40 to 30, which is 30 centimeters, which is 0.3 meters. And that is the tricky part of this question. And the rest, you're just going to need your fat, moody dinosaurs. And it says calculate the weight, that's the force. And we can see that the force equals the moment divided by the distance. And it gives us our moment there. We've now changed that distance into meters, and we can just divide the two to get 2 newtons. Show that the total moment of S and R about P is 0.07. So we've got S to R, so 10, 20, 30, that's 40 centimeters, which is 0.4 meters. Got to do that change because we can see here that's there. And then we can go through and it tells us that the weight of R is 1 newtons. So now we're ready. So show and the total. So we've also got 10 times 2. So because we've got 2 turning moments here. So it's gone a bit messy. So let me just do that again. So we've got S and R, and if I just get rid of all the doodles, I did that far too quickly. We can see we've got this one here, which is 0.1 meters. We've got this one here, which is 10, 20, 30, 40, sorry, 0.5 meters. And then we know that that one's 2 newtons and that one's 1 newtons. So we're just going to work each of those out using our fat, moody dinosaurs and then add the total clockwise moment. So there we go. That's it calculated. Now, clearly I've been a div because these bits are wrong, but I'll go back there. So it says using the data in the question and the principal moments. So we know that at equilibrium, total anti-clockwise moment equals total, and that's really important, clockwise moment. It says the rod is very light, so its weight can be ignored. So what we got to do, well, we worked all of that out last time. We were given that in the previous question. And then we've just got to say, no, the clockwise moment is greater than the anti-clockwise moment. So we'll have a turning moment in the clockwise. So it's just using all the information that we worked out in the previous one. Okay, we've got a rack and pinion. The teeth on the rack are 8 centimeters apart. It says calculate how far along the rack the train moves when the pinion turns through 1 complete. So that's the pinion there. So what you'd have to do, count up the teeth, and there's 20. We've got 20 lots of, because it wants the distance in meters, so we're going to have to change the centimeters to 0.08 meters. And then we're going to have 20 lots of 8 centimeters, or 20 lots of 0.08. So it'll move 1.6 meters in total.